Hi everyone, for today's video we are now on our chapter 11, the switch security configuration. So we have here the implement port security and secure unused ports. It is a simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. For example, if a Catalyst 2960 switch has 24 ports and there are 3 fast Ethernet connections in use, it is good practice to disable the 21 unused ports, navigate to each unused port, and issue the Cisco IOS shutdown command. If a port must be reactivated at a later time, it can be enabled with no shutdown command. To configure a range of ports, use the interface range command. As you can see here in our figure, shutdown ports for FA08 through FA024 on switch 1. You would enter the following command. So, interface range FA08 to 24. Then, no shutdown and link changed. Mitigate MAC address table attacks. Port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security services a frame, the source MAC addresses of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. By limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network as shown in the figure. So this is our port and allowed MAC. So our allowed MAC is a 401 and our MAC BAAD01 is not compatible with a 02 and MAC BAAD02 is not compatible to the 03. MAC addresses are shown as 24 bits for simplicity. Enable port security. Notice in the example, the switch port security command was rejected. This is because port security can only be configured on manually configured access ports or manually configured trunk ports. By default, layer 2 switch ports are set to dynamic auto or trunking on. Therefore, in the example, the port is configured with the switch port mode access interface configuration command. Use the show port security interface command to display the current port security setting for fast Ethernet 01 as shown in the example. Notice how port security is enabled, the violation mode is shut down, and how the maximum number of MAC addresses is 1. If a device is connected to the port, the switch will automatically add the device's MAC addresses as a secure MAC. In this example, no device is connected to the port. Port security is enabled, violation mode shut down, and the maximum MAC addresses is 1. After port security is enabled, other port security specifics can be configured as shown in this example. Aging port security aging commands, MAC address, secure MAC addresses, maximum MAC address, MAC secure addresses, violation security, violation mode. Limit and learn MAC addresses. To set the maximum number of MAC addresses allowed on a port, use the following command: switch config if hashtag switch port security maximum value. The default port security value is 1. The maximum number of secure MAC addresses that can be configured depends the switch and the IOS. In this example, the maximum is 8,192. So, we have here interface F01, switch port security maximum, and the switch port security maximum. The switch can be configured to learn about MAC addresses on a secure port in one of three ways. Manually configured. The administrator manually configured a static MAC addresses by using the following command for each secure MAC addresses on the port. Switch port security MAC addresses, or our MAC address, dynamically learned when the switch port security command is entered. The current source MAC for the device connected to the port is automatically secured but is not added to the startup configuration. Dynamically learned sticky. The administrator can enable the switch to dynamically learn the MAC address and stick them to the running configuration by using the following: switch port security MAC addresses sticky. Saving the running configuration will commit the dynamically learned MAC addresses to NVRA. The following example demonstrates a complete port security configuration for the Fast Ethernet 01. The administrator specify a maximum of 4 MAC addresses, manually configures one secure MAC address, and then configures the port to dynamically learn an additional secure MAC addresses up to the 4 secure MAC address maximum. Use the show port security interface and the show port security address command to verify the configuration. So this is our diagram. So we have here our interface FA01, switch port mode access, switch port security, switch port security maximum of 4, switch port security MAC address, the MAC address, and our sticky, and then end. Our port security aging. Port security aging can be used to set the aging time for static and dynamic secure addresses. On a port, 2 types of aging are supported per port: the absolute and inactivity. We have the parameter, static, time, type absolute, and type inactivity. For our port security violation modes, if the MAC addresses of a device attached to the port differs from the list of secure addresses, then a port violation occurs by default. The port enters the error disabled state. So, we have security violation mode descriptions, the shutdown, then restrict, and protect. Shutdown, of course, the port transitions to the error disabled state immediately. Restrict, port drops packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. Protect is the least secure of the security violation modes. Security violation mode comparison. Violation mode, protect, restrict, and shut down. Protect has a discard offending traffic but no sense syslog message, increase violation counter, and no shuts down ports. Restrict has a discards offending traffic and sends syslog message but and increase violation counter but has no shuts down port. Shutdown has all of this. Ports in error disabled state. When a port is shut down and placed in the error disabled state, no traffic is sent to or received on that port. A series of port security related messages display on the console as shown in the following example. So this is our example. In the example, the show interface command identifies the port status as disabled. The output of the show port security interface command now shows the port status as secure shutdown. Verify port security. After configuring port security on a switch, check each interface to verify that the port security is set correctly and check to ensure that the static MAC addresses have been configured correctly. So, we have here show port security. Then, these are the list of secure port, the count of secure address, current address, and security violation, and the security action. Use the show port security interface command to view details for specific interface as shown previously and in this example. So, show port security interface fast Ethernet 0/18. The port security is enabled. Port status is secured up. Violation mode shut down. Aging time 0 minutes. Aging type absolute. Secure static address aging is disabled, and so on and so forth. Syntax checker implement port security. Implement port security for switch interface based on the specified requirements. So, we have here the you are currently logged into S1. Configure Fast Ethernet 054 port security by using the following requirements. This is our figure that we're going to configure Fast Ethernet 05 for port security by using these following requirements. Use the interface name FA05 to enter interface configuration mode. So this is our interface FA05, and switch port mode access, because here enable the port for access mode. Enable port security, switch port security, set the maximum number of MAC address to 3. Switch port security maximum of 3. Statically configure the MAC address AAA BBB 1234. And that's it. Enter command to verify the port security for all interfaces. That's it. For our mitigate villain attacks, I'm going to show you this implement port security using a pocket tracer on my next video. So for now, we're going to mitigate villain attacks. Villain attacks review. As a quick review, a villain hopping attack can be launched in one of three ways: spoofing the TP messages from the attacking host to cause the switch to enter tracking mode, introducing a rogue switch and enabling tracking, and another type of villain hopping attack is a double tagging attack. Steps to mitigate villain hopping attacks. Step 1. Disable DTP negotiations on non-trunking ports by using the switch port mode access interface configuration command. Disable unused ports and put them in an unsaved VLAN for our step 2. Step 3. Manually enable the trunk link on a tracking port by using the switch port mode trunk command. Step 4. Disable DTP or our auto-trunking negotiations on tracking port by using the switch port no-negotiate command. Step 5. Set the native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN or our VLAN number command. Syntax checker. Mitigate villain hopping attacks. Mitigate villain hopping attacks on the switch based on the specified requirements. So, we're going to currently log into S1. The port status of the ports are as follows. Fast Ethernet port 01 through 04 are used for trunking with other switches. Fast Ethernet ports 05 through 010 are unused. Fast Ethernet ports 011 through 024 are active ports currently in use. So, we have here the switch port mode trunk, switch port non-negotiate, and switch port trunk native VLAN 99 and then exit. Use range of FA05 to 10 to enter interface configuration mode for the trunks. Range FA05 to 10. You must enter exact full command. We have configure the unused ports as access ports, assign them to VLAN 86 and shut down the ports. We have the switch port mode access, the switch port access VLAN 86, and here's the result. Creating VLAN 86, then shut down. Interface range FA011 to 24, switch port mode access, and then end. Then, mitigate DHCP attacks. DHCP attacks review. The goal of a DHCP starvation attack is to create a denial of service for connecting clients. DHCP starvation attacks require an attack tool such as Gobbler. DHCP snooping. It does not rely on source MAC addresses. Instead, DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. Devices under your administrative control, such as switches, routers, and servers, are trusted sources. The square with a color of violet are the trusted port, and the untrusted port is a red circle. Steps to implement DHCP snooping. Step 1. Enable DHCP snooping by using the IP DHCP snooping global configuration command. Step 2. On trusted ports, use the IP DHCP snooping trust interface configuration command. Step 3. Limit the number of DHCP discovery messages that can be received per second on untrusted ports by using the IP DHCP snooping limit rate interface configuration command. And step 4. Enable DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping VLAN global configuration command. And these are the steps to how to implement the DHCP snooping. DHCP snooping configuration example. The reference topology for this DHCP snooping example is shown in the figure. Notice that our F05 is an untrusted port because it connects to a PC, this one. And F01 is trusted port because it connects to the DHCP server. And this is our DHCP server. The following is an example of how to configure DHCP snooping on switch 1. Notice how DHCP snooping is first enabled, then the upstream interface to the DHCP server is explicitly trusted. Next, the range of fast Ethernet ports from FS05 to FS024 are untrusted by default, so a rate limit is set to 6 packets per second. So this is our figure, IPDHCP snooping, interface F01, IPDHCP snooping trust, and then exit. So next, interface range F05 to 24, IPDHCP snooping limit rate to 6, and then exit. And we have here the IPDHCP snooping VLAN 510, 50 to 52, and then end. Syntax checker mitigate DHCP attacks. Implement DHCP snooping for a switch based on the following topology and specified requirements. So, here's our S1 config with IP DHCP snooping, and here interface range G01 to 2, IP DHCP snooping trust, and then exit. For our mitigate ARP attacks, we have dynamic ARP inspection. In typical ARP attack, a threat actor can send an solicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. Dynamic ARP inspection, or DAI, requires DHCP snooping and helps prevent ARP attacks by not relying on invalid or gratuitous ARP replies out to other ports in the same VLAN. Intercepting all ARP requests and replies on untrusted ports, verifying each intercepted packet for a valid IP to MAC binding, dropping and logging ARP replies coming from invalid to prevent ARP poisoning, error disabling the interface if the configuration DAI number of ARP packet is exceeded. DAI implementation guidelines. Enable DHCP snooping globally. Enable DHCP snooping on selected VLANs. Enable DAI on selected VLANs. Configure trusted interfaces for DHCP snooping and ARP inspection. It is generally advisable to configure all access switch ports as untrusted and to configure all uplink ports that are connected to other switches as trusted. The sample topology in the figure identities trusted and untrusted ports. We have here our PCA, and this one is our VLAN 10. We have here the threat actor and the untrusted port of F01 and F02, but we have here the trusted one, our F024. DAI configuration example. Destination MAC checks the destination MAC address in the Internet header against the target MAC addresses in ARP body. Source MAC checks the source MAC address in the Ethernet header against the sender MAC addresses in the ARP body. IP addresses checks the ARP body for invalid and unexpected IP addresses, including addresses 0.0.0.0. or our 255.255.255.255 and all IP multicast addresses. Here our figure which has IP ARP inspection validate. Then inspection validate SRC or MAC, and our do show run include validate, and do show run include validate with IP ARP inspection validate SRC MAC, DST MAC, and IP. Syntax checker or mitigate ARP attacks. Implement DAI for a switch based on the following topology and specified requirements. So our F01 IP DHCP snooping. Then our interface range G01 to 2 IP DHCP snooping trust, IP ARP inspection trust, and exit. And we have the VLAN 10, 20, 30 to 49 and ARP inspection VLAN 10, 20, 30 to 49. Mitigate STP attacks. Port fast and BPDU guard. Port fast is immediately brings an interface configured as an access or trunk port to the forwarding state from a blocking state by passing the listening and learning states. Apply to all end user ports. Ports fast should only be configured on ports attached to end devices. BPDU guard. Guard immediately error disables a port that receives a BPDU, like port fast, BPDU guards should only be configured on interfaces attached to end devices. In the figure, the access port for S1 should be configured with port fast and BPDU guard. Configure port fast. Port fast bypasses the STP listening and learning states to minimize the time that access port must wait for STP to converge. If port fast is enabled on a port connecting to another switch, there is a risk of creating a spanning tree loop. To verify whether port fast is enabled, globally you can use either the show running config or begin span command or the show spanning tree summary command. To verify if port fast is enabled an interface, use the show running config interface type number command as shown in the following example. The following spanning tree interface type number detail command can also be used for verification. Configure BPDU guard. If any BPDUs are received on BPDU guard enabled port, that port is put into error disabled state. This means the port is a shutdown and must be manually re-enabled or automatically recovered through the disable recovery cause P secure violation global command. Syntax checker mitigate STP attacks. So you are currently logged into S1. Complete the following steps to implement port fast and BPDU guard on all access ports. Enter interface configuration mode for FA01. So here it is. Next, configure the port for access mode, switch port mode access, and next return to global configuration mode, our exit. Spanning tree port fast default, enable port fast by default for all access ports, and lastly exit. And show spanning tree summary. And that's all for this video, our chapter 11, switch security configuration. See you to my next video.